يتفضل الآن سعادة العميد راشد الفلاسي مساعد المدير العام للخدمات الذكية في الإدارة العامة للدفاع المدني بدبي لافتتاح الجلسة النقاشية التي يديرها السيد بيتر رئيس فرع الخليج والشرق الأوسط لجمعية مهندسي الإطفاء. Mr. Peter, the floor is yours.
It's been a very, very interesting morning so far. Just to run through how the discussion panel is going to be operating today. I'll introduce the panel. Are we going to have some seating brought up for the panel? Maybe if we can have some seating brought forward for the panel, that would be appreciated. We have 7 panellists. 2 of the panellists are going to be new to the forum this morning. They are silver sponsors and also the HVAC partner for the event. I'll introduce them with a bio, and then we'll move into general questions. I have some pre-prepared questions, and then we'll have more of an open forum where people can ask questions from the floor. We've heard a lot about the Grenfell fire today, and I'd like to ask anyone in the audience to be very sensitive about any questions that are asked, because in the UK there are investigations still ongoing, so please just be very, very aware of that. We've heard a lot today about building safety, whole life cycle safety. Also, we've heard presenters mention about having a better understanding of the built environment. HGT mentioned about extreme events that have taken place and how these impact on building safety. It's very common to see fire strategies written for buildings that actually only take one single fire scenario into consideration. What does happen if we have an extreme event that causes a fire? It could be an earthquake, as I mentioned, landslide, flooding. I think holistically we need to think outside the box to make sure our buildings are safe for our ageing population, people with disabilities, people that may have a mental disorder that can't react to a fire alarm as a normal person might be able to. So I think these are all things that hopefully we can generate some questions as we move on. So what I'd like to do is actually introduce the panel onto the stage. Firstly, Brigadier Rashid Falassi, who is the Assistant Director General for Smart Systems in Dubai Civil Defence. Brian Fagan from Warringtonfire, one of the silver sponsors. Karim Badruddin, the HVAC Fire Safety Partner. HGT, representing the IFE from Malaysia. John Runkle from ASTM. Paul Walker, representing the UK Fire Service. And Sebastian from the Emirates Safety Laboratory. If you could join us on the stage. And firstly, I would like to ask the Brigadier Rashid Falassi, if you would just like to take a few moments to talk about the Fire Safety Forum and the impact and the positivity that it has generated within the UAE and across the GCC.
السلام عليكم ورحمة الله وبركاته. بداية طبعا أرحب بجميع الحضور من السيدات والسادة وكبار الضباط بالإدارة بالقيادة العامة للدفاع المدني، وأشكر جميع الخبراء الذين شاركوا في هذا الملتقى السنوي التاسع، والذي دائما ما يحرص سيدي سعادة اللواء خبير راشد ثاني المطروشي مدير عام الإدارة العامة للدفاع المدني دبي بأن يكون هذا الملتقى من أفضل الملتقيات تميزا في المنطقة. طبعا نظرا لظروف فنيابة عنه أعتذر لاضطراره ترك الملتقى، وكذلك العقيد خبير علي حسن المطوع طبعا المنسق العام لهذا الملتقى السنوي. نجاح هذا الملتقى السنوي لم يكن لولا مشاركتكم وحضوركم ووجود هذه الكوكبة من الخبراء اللي يتم استقطابه، وهذا التزاما منا نحن كإدارة عامة في الدفاع المدني دبي أن نستقطب خبراء على مستوى العالم لجلب هذا الخبراء في دولة الإمارات العربية المتحدة للاستفادة من خبراتهم المتراكمة وممارساتهم وتجاربهم. طبعا التوجه العام لدولة الإمارات العربية المتحدة كرؤية بأن يتم مستقبلا الاستثمار في الاستشراف، الاستثمار في الذكاء الاصطناعي، وكذلك الاستفادة من الخدمات الذكية وزيادة مساحة هذه الخدمات فيما يتعلق بخدمات الدفاع المدني. طبعا التحديات كثيرة، ولكن نحن لدينا الثقة في أن مجتمع دولة الإمارات العربية المتحدة وطبعا المجتمع الدولي أصبح يتفهم أهمية سلامة طبعا هذا العالم الذي نحن نعيش فيه. نعمل جاهدين بتوفير أعلى معايير السلامة في المباني، في المنشآت الصناعية لضمان سلامة مجتمعنا. طبعا أخيرا نيابة عن سيدي سعادة اللواء خبير راشد ثاني المطروشي، ونيابة عن العقيد خبير علي حسن المطوع، وأصالة عن نفسي العميد راشد الفلاسي، أتقدم بجزيل الشكر لجميع المتحدثين الذين أثروا ملتقانا اليوم بطرحهم وما قاموا بتقديمه من محاضرات، وشكرا.
شكرا. Now it's my pleasure to introduce our silver sponsor from Warringtonfire, Brian Fagan, who will give a short overview of Warringtonfire in the Middle East. Brian has a BSc Honours degree in Building Services Engineering from Dublin Institute of Technology and a Masters in Fire Safety Engineering for the University of Ulster in Northern Ireland. With 13 years of experience working in the UK, Australia, Ireland and the UAE, his knowledge is broad within the fields of fire engineering, risk assessment and project management. Brian has extensive technical expertise in all areas of fire safety engineering and has worked on a wide range of prominent projects from rail through to residential to theme parks. He is also a member of the Institute of Fire Engineers and is registered as a chartered fire engineer with the Engineering Council. Please welcome Brian.
Thank you, Peter, for that warm introduction. Good afternoon, ladies and gentlemen. On behalf of Warringtonfire, I'd just like to say how delighted we are to be here today, supporting this prestigious event. I'd also like to extend a warm thank you to Dubai Civil Defence and to the Major General for welcoming us here today and permitting us to talk about our company and also speak on a special topic. So who are Warringtonfire and Element? Warringtonfire is part of the Element Group, and as a company we specialise in testing and certification, and that's why today's forum is of particular interest to us. The Element Group, we're an international organisation. We've over 6,700 engaged experts worldwide. We service over 40,000 customers in 189 locations in over 30 countries. Why do we exist? Our purpose. We help to make certain that the materials and products we test, inspect and certify are the following: safe. Safety is our core value. Quality, compliant and fit for purpose. We're involved in 4 high-value services: testing, certification, calibration and advisory. And we service 4 sectors internationally: aerospace, transportation and industrials, oil, gas and infrastructure, and fire and building products. I just want to focus today, obviously it's a fire safety forum, so to speak about fire and life safety and fire and building products. In terms of fire and building products, we service an international client base as well. We have a broad spectrum of office locations, starting in Ireland and Dublin. We have extensive offices across the UK, through the Middle East, and then also in Europe and in Australia. And just to get back to the topic of today's forum, really, and Paul talked about it earlier on, it's total building assurance over the life cycle of the building. We see this as a 4-part process that begins with stage 1, the design concept for the building. We see this as a collaboration with all stakeholders, which would include the design team, insurers, Dubai Civil Defence predominantly for ourselves, and also other engineers and members of the design team. It's important at the outset of a design to specify the codes and standards that you'll be following, and then to work on the fire strategy, whether it be a prescriptive design or performance-based. The cause and effect strategy is also something that should be discussed at the outset to ensure that the building design is going to be implementable when it's finished. Moving on then to specification. So today we talked about fire testing and certification, but again, if you don't know the products that you're specifying in the building and whether they're fit for purpose and being used in the right location, it can cause issues. As an organisation, we can also conduct bespoke fire testing of systems in the UK. Moving on then to the construction phase. So inspection is critical at the construction stage. We will also inspect active and passive systems to ensure that the building is being built in accordance with the fire strategy and what's been specified, and also carry out cause and effect testing. And then moving on to the handover. The documentation all throughout the design process is important to be handed over so that the building management company can understand how the building functions and what the fire strategy was based upon. Training of the facility management is also important, and then also something that Paul spoke about earlier, just a health check of buildings. We see this as a critical, it's a 4-stage process, but over the life of the building, this is really fundamental in order to ensure that we have safe buildings and that we're keeping up with standards and industry guidance. So that's all I have to say really today, so I'll just pass you back to Peter. Thank you.
Thank you very much, Brian. Thank you. And I'd like to now introduce Karim Badruddin from the Managing Director of Central Ventilation Systems. They are the HVAC fire safety partner for the event. And Karim, if you'd maybe just like to say a few words about CVS.
Good afternoon, ladies and gentlemen. We are manufacturers of fire-rated products based in the UAE. From the last 15 years, our focus is on fire industry and passive fire products core, manufacturing of fire ducts, dampers, attenuators, and catering HVAC industry. That's it. Thank you.
Karim has over 14 years of experience and has been contributing to the development of the regional HVAC industry through passive fire safety solutions. He's led several product development initiatives, including the region's first non-coated fire-rated ductwork systems. Karim focuses his attention on creating awareness about recent requirements of the latest UAE Fire and Life Safety Code of Practice within and amongst his industry peers, and highlights passive fire protection as an integral part of HVAC best practice. And I know Karim is very passionate about testing and certification of smoke-controlled ducting systems. And I think to actually sort of get the questions going, I'd like to just put a question to you, Karim. With regard to smoke-controlled duct systems, full systems should be tested for their integrity, stability and insulation. But I think within the industry there needs to be a little bit of clarity on what is the definition of a full system. Maybe you could elaborate that for us.
Ductworks, dampers, different components are used in extraction of smoke during fire. The most important factor here is all the components should be tested as a system, not individually or, incomplete systems. Just the ducts have been tested and other parts are not tested, and they're fixed together and they're presented as a system, as a smoke management system, which has a higher probability of a failure during fire. And this is what the problem is, and we are here to address the whole system. We emphasize on the word called system. All the parts and the components should be having an equal rating of integrity and stability to perform.
Okay, thank you. And we mentioned insulation there. What is the insulation criteria, at what temperature and where to use insulation within the system?
Well, the different guidelines available to use insulation on smoke extract system. We have to understand that design dictates us where to use insulation and where not to use insulation. We don't dictate that terms. Again, as a manufacturer, we follow instructions, we follow guidelines, specifications, design rules, regulations by engineers. Based on that, we have to understand what are the best solutions to achieve the requirements of the codes and different specifications based on NFPA and other regulations around. Insulation is a subject, we are very thankful to the new code committee to clarify or has given a clarity on what insulation requirements are on a fire product. But still, we are still lagging on the designs, where to use insulation properties and why should we have insulation. There are certain areas insulations are not required, and there are a lot of areas where insulations are required. So we have to get clarity, better clarity on where to use insulation and where not to use insulation.
Okay, thank you. Is there anyone else on the panel, maybe Sebastian, any views on testing and ductwork, etc.?
Oh, I'm glad you mentioned the point that the whole system should be tested, and it's our view in Emirates Safety Laboratory, and we're trying to promote that view during our recent, let's say, talks, that not only the component should be tested, but the system should be tested, for example, by the hot smoke test, which is like Australian standard, but is used worldwide, and that's the only way to assess that the system, especially a smoke extraction system, especially in the large assembly like the malls, should be tested and evaluated, because you as manufacturer can have a really great product, but if it's not designed to fit the purpose, I mean designed not by you but by the consultant, or it's not installed as it should be, or the automation is not working as it should. So there is no benefit of great product which is not working properly. So we're really trying to promote and that hot smoke testing which is really applicable to your product, which is kind of on-site testing, which answer the question if the smoke extraction is designed, installed, and working properly. It's really important. So that would be my comment to that question.
Okay, well, thank you. Just on that thing then, with regards, we talked about, or as mentioned in several presentations, the Steiner tunnel test. With regards to sort of meltable materials, foams and sort of plastic sheeting, etc., how do you actually sort of see, is it actually fit for purpose? Is there any comments on that?
So the question was if the material, which I understand, type of plastic which melts or dripped, how this can be assessed and be fit for purpose by this test, if I understand the question properly. Yes. So our view, I mean, for those of you who are really in-depth knowledge of the test, the standard says that this test is not appropriate for materials which melt, drip, and behave on the way that the flame front is lost. So that's why our view, which I presented during the presentation, is that we really should go towards the tests which use the heat release rate measurement. So in either the European approach with SBI or the room corner approach in United States. So that's our answer to the problem of materials which not behave well in that test.
Thank you. And again, another question for you, and maybe bring John into this one. Sort of in your opinion, with approvals, UL, ASTM or EN, which leads to a better assessment of fire performance, of fire resistance, especially with insulation materials?
I'm afraid this is really a tricky question, and I like the approach of the presenter from Saudi Aramco, who said that really he preferred not to refer to any particular listing or approach, and obviously there are benefits of each system and there are disadvantages of each system. So our aim as the laboratory and the certification body is to guide the clients not to just pass, to get the pass mark, but to introduce the products on the market which are, let's say, safe to the expectation. So my answer would be, there is no definitive answer. I cannot say that this is better than the other. there are the disadvantages and advantages of each approach. And I don't know if other members of the panel have something to add on
maybe
that.
if John, if you would like to, I'm sure you have some input on that question.
I appreciate the question. I think I will repeat one of the things I said before, and I think when you're looking at a system or an assembly, you should try to test a system or assembly. When it comes to a material, there's a lot of tests that have weaknesses, and we went through a lot of them today. And so when we as an industry know that there's a weakness with a certain test that might show a material that passed where it doesn't feel like a pass or shouldn't be a pass, then we should get together and we should continue to read the fine print, and come up with tests that work for those materials. And so maybe it's adding on some benchtop testing to some of the larger scale testing, because we know what the right thing to do is. And so that's really where the future is. Close the gap with some new standards and use the benchtop to fill in some of the gaps.
Thank you. And maybe, Paul, if I could bring you in, because you mentioned during the presentation, which rang in accord with myself, because my background was previously in the UK Fire Service, and I was probably in the era where the training was very good through the Fire Service College, both operationally and through fire safety. And you mentioned that now has sort of, over time, petered back, where the operational fire crews probably don't understand the wider built environment and the way buildings are put together. And the discussion on fire testing standards, etc., is all interactive with building design. I just wondered if there's any observation from an operational perspective and building design and approvals.
Yeah, thank you. I mean, my observation would be, and I think it's in line with the other panellists today, is to say that you can do the individual testing, but whole system testing should be done at a commissioning stage and then maintained throughout. And then I think the involvement of local fire and rescue in that commissioning stage will increase their understanding. Of course, I think there has been a skills decline in terms of building construction within frontline operational crews, and I'm talking about in the UK. But I think through the National Fire Chiefs Council, we're addressing that, and many of my colleagues across the UK are introducing that back into the firefighters' core competencies. And I think you'll see firefighters starting to understand means of escape compartmentations and some of the life safety systems that are installed in modern day buildings.
Lovely, thank you. And maybe HG, would you like to have any observations on that? You mentioned about refuge floors and the such like.
No, I think first of all we have to explain one thing. It seems to me that we in UAE Civil Defence, we have taken and encouraged to have our own local code, which it was basically implemented from the international worldwide codes such as NFPA and such as EN and such as UL. But at the end of the day, I'm supporting 100% my colleagues from Aramco when he said that we required a certain standard to be applied when it comes to testing and when it comes to code, when it comes to building. Because I used to be a member of NFPA, and I was always discussing even during Jim Shannon period. We couldn't find a really clear code that we can stand on solid. So the decision came up from His Excellency that we have to have our own local code based on our experienced fire officers, and at the same time based on consultant engineers' offices, based on contractors, based on even though the agent and manufacturer locally. We came up with the standard. We think that it is really matching with our environment, and I think with the activation of ESL, I think we will come up with the standard mixed up, because we cannot invent anything as been said by the key speakers, but we can come up with a standard match with our environment, match with our challenges, which is totally different than any other part of the world. So that's, I think, my commitments. And as we said earlier, we are committed for our community, and I think we will going to achieve that with the ESL in UAE.
I think, I've been now in the Middle East just over 6 years, and I think the way the UAE and Dubai Civil Defence have moved forward with the code, etc., has been sort of first class, and it's very, very, very commendable. And with HG, would you like to?
Okay. First of all, is that I think the testers now to be carried out in the lab should be more fit for purpose. In the past, it's just fulfilling a test, get it passed, and then start to market it. I think there are a lot of things we have not actually looked at it carefully. For example, one of the issues brought up by Professor Jose Torero is that when we test in the lab, the system are attached to an element. It could be a masonry wall or whatever. But sometimes the application when it goes into the market is attached to a drywall partition, which is totally different because the building material behavior is different. And it's not only the system that have to perform, but also is being affected by the coefficient of expansion of different materials. So at times, if you test it on A material, it's acceptable. But when you move it to B material as a background, it changes the entire performance of the system. So this is one part of it which I think needs further research and then come up with some data. I give you a typical example. In Malaysia, there are a lot of fire doors. When they tested in the laboratory, they're built into brick walls. But so many of them were actually now installed on drywall partition. Now, if you install on drywall partition, the partition is not bearing, so you need a H frame instead of C frame. So up to now, everybody just introduced it to a drywall partition without thinking about the consequences. So if you have a H frame of a fire door that is bolted to the soffit of the ceiling and the floor, it makes a lot of difference. The partition might not be able to carry the load of the entire fire resistant door set because it's very heavy. Not only the doors are heavy, frames are heavy. So the way I look at it, there are still certain issues that we need to resolve. It's not just testing in the lab and apply. As for the refuge floor, I think it actually has become a norm now in Singapore, in China, for buildings, the so-called super high-rise buildings. You definitely need a refuge floor. The reason is that I think most of us agree that nobody can just walk down from 80th floor. So for those people who are tired, if you do not let them rest, they are going to actually cause a slow egress path inside the staircase. And then eventually you're going to have a stampede because people at the back who are faster, they get impatient, they'll start to push. The moment somebody fell in the front, nobody escapes. So the point of having a refuge floor at every 25 floors interval from the ground level is such that when you move down from a staircase, you actually have to actually go around that refuge floor where people who are tired will take a rest and the rest will continue on alternate staircase. This virtually solves quite a lot of engineering problems is because at the moment our staircase is all the way down, even for 80th floor. Now, how are you going to prevent smoke egress into the staircase? If you have high-rise buildings, normally you have 2, maximum 3 staircases. If they are compromised, you imagine the full density of the occupants will have to go and rely on one fire escape staircase, 80 floors, which is not sustainable. So when you actually have refuge floors on 25 floors interval, you actually break the staircase into different sections. Now, to prevent smoke particles getting into the staircase, if you pressurize the staircase, it also solves another problem because to pressurize a staircase of 80 floors is virtually impossible and very difficult.
It is a very good point, that, and it ties in again to the evacuation strategy. If you have to go from phased evacuation to simultaneous evacuation, that can seriously compromise your pressurization. And maybe that's, Karim, any observations on the smoke control systems and ductwork, etc., particularly in relation to refuge floors?
Again, it comes back to the designs. The designers has to understand what to do, how to do, when to do, and how much to do. It's all about design. The capacities of the fans, the exchange of the airs, how much pressure do you need, locations of the equipments in a very sustainable manner. It has to be properly designed.
Absolutely, and checked, commissioning,
and
etc.
checked, definitely.
Very, very, very important. I'm going to open the floor to questions in a moment. Have we got a roving mic or microphones going around? There's just one more question, if we can get ready for the questions to the floor. There's just one thing I want to backtrack to, because it came up in HG's presentation, and it's again relevant from Sebastian's point of view with regards to heat release. Now, HG, I think you made a comment about the importance of heat release in modelling and in fire dynamics, how important it is to measure that. What are the benefits of doing this more in-depth measurement of the heat release rate?
In terms of?
Was it in your presentation you mentioned the importance of heat release for checking for the dynamics of testing of the structures? I think it was in your presentation you put a graph up that did the correlation between 3 different fire scenarios.
3 different fire scenarios.
I think it was the heat release rate of the cladding panels. I think that was your presentation.
If you look at the cladding issue, basically, if we actually can put a cladding that is using non-combustible materials, then definitely you will remove all the risks, the way I look at it. But then, if you look at current trend on the market, we are talking about green building index. Green building index looks at preservation and conservation of energy. Now, why this insulation material has been largely used in temperate climate countries is because if you look at UK, during winter time, they're very cold. Now, if you use proper or high K value insulation materials, you will actually save a lot of heating bills. In Middle East, it's just the opposite. Your ambient temperature is so high, you need a lot of air condition bills. So if you were to put in a good insulation material with a high K value, of course you save your aircon bill. But the point is, good insulation material with high K value, of course there's 2 choices. You use full non-combustible material that is going to be expensive, it's going to be heavy, you're going to add weight to the structural, what we call expenses. So normally the choice from the market will be to use the cheapest, right? Cheapest, light, easy to work. But they've forgotten that if you can go that route, but yet you're introducing a high fire risk to the entire building. And initially you might save a lot of money. Ultimately you actually have a problem, but you virtually cannot solve. And it's going to involve a lot of money, which is happening now, right now.
And Sebastian, maybe from ESL's point of view, any observations on the importance of measuring heat release?
So as it was shown in the presentation, you know, if we measure the basic question with the fire is how big can the fire develop? If really the non-combustible materials are not used very often, so in our opinion, the proper approach is to measure how much heat is released during combustion of the materials, and then we can link that to the real scale fires, and that's why the measurement of the amount of heat, which is heat release rate, it shows us the propensity to flash over the potential of the fire to develop to untenable on uncontrolled conditions. So that's why we fully support this approach in assessing the reaction to fire of materials.
And that will feed back into the original design where the design fires should be agreed as part of the initial design phases. So it's all very important to make sure we do connect all these elements. Now, I'm going to move over to the floor now, so if there's any questions from the floor, if you could raise your hand, and if someone can go out with one of the microphones. If I could ask members of the audience to ask single questions, not multiple questions, and just to keep it specifically 2 questions and not any sort of other sort of evolution of that.
Yes, my name is Abdullah Faza from Lockheed Fire Consultancy. I'm here, yeah, on your left side. Okay, so we've been doing a lot of facade assessments as a house of expertise approved by Civil Defense. We understand that there is a classification and testing for every single system. So my question is, how about the projects when you have more than one facade system. For example, I've been doing projects with about 5 different facade elements like curtain wall, ACP, GRC, and the IFS systems. So what is the benchmark for us to come up with the final assessment decision?
Okay, thank you. Sebastian, would that lead in nicely to a response from ESL?
So I will try to respond on behalf of ESL. So as far as I understand the question properly, you have like five different design of facade, and I'm not sure if I understand what you mean by benchmark, but because I don't know the details of the project, so it's hard to answer here on the audience. But if we are according to UAE code, which is like the way how things should be assessed here, of course you have the requirements for the elements, which is test 1, and you have requirements for the whole assembly, which is test 2. But then I honestly don't know what are differences between your different facades. So if they're completely different, of course they should be evaluated separately. The code is allowing some engineering judgment, but this should be reasonable. And also the code is saying that the engineering judgment should not be a substitute to the testing. So without knowing more details, I cannot answer here.
Okay, I will just give you a quick example. For example, if we have 2 different facade elements in one project, I'm talking about the interface between these facade elements. So how to judge it. So for example, you may have an ACP system being tested as simply with a rock wall insulation, and you have another GRC system being tested with a glass wall insulation. And these 2 systems will be placed in one project. So in such interfaces, how can we come up to a last decision? This is what I mean. When it comes to the interfacing between these 5 systems.
I mean, I think that the question is too specific for the audience, and I would be happy to answer it during the chat after the panel. But obviously, if the let's say interfacing element is like existing perimeter barrier system, then it should be assessed with respect to those 2 systems. But because it's really, really specific and not sure how relevant to the whole audience, I'm happy to discuss it after the panel, okay?
Thank you. Maybe John would like to sort of say a bit on this subject, but I think it's very, very important to understand with the full design, these sort of items should be picked up early on. So there shouldn't be any surprises at the end. And from Civil Defence's point of view, they would need to be reassured that the products, the manufacturer, all the system materials are approved, and then the coming together of the system for testing, and also, as Sebastian mentioned, the engineering judgment, it all plays a big piece in the overall design. Very important to get these things out early into a design for discussion to make sure there's no sort of failures or horror stories at the end from an approvals point of view, I think. Okay. Next question from the floor.
Sabiq Isaf, Hyperloop Transportation Technologies. My question is related to new technologies, and we heard the panel talking about the testing of the components and the system as a whole. If I'm talking about a system which already have most of the component tested, but the whole system is not being tested. When I'm applying for my fire strategy for a future Hyperloop system, do I have to submit all the testing for all components or just the components which not being tested? Thank you.
Brigadier, would you like to respond?
To your question, it seems to me that whatever test required to be taken as a fire prevention or a fire rated, it has to be for the full components. You cannot make a test for a part or a service away from the full components, because any part may fail that will lead into a full failure of the full components. So we do recommend the full components to be tested.
In answer your question, I think you're looking at system testing. Component testing, we have really found that it doesn't work anymore, all right? And in many fire incidents, it's not only in Grenfell. Component testing means that you test one part of a system, but you must understand a system consists of so many parts, and each of these parts must be able to work with each other during a fire situation. And you know that each of these components, they behave differently in a fire. So until and unless you put all of them together and test and fulfill the fire rating requirements and all the criteria, you will not know whether, even though you test each of the components that actually comply with their respective standard, which is different from the system standard, testing standard, you will never know. And it's very, very dangerous to assume that if components pass a test, if you put all of them together, it's going to work as a system. I just give you an example. In the past, in Malaysia, when a fire door tested a system, the contractor and the developer only buy the door lift from the manufacturer and tell the manufacturer, my cousin supplied the frame, the other cousin supplied the ironmongeries. Different ironmongeries from where he tested, and it resulted in a lot of failures. So ultimately, the authority, with our help, says that no. If manufacturers, because this fire door system is proprietary, manufacturers select the material, select the design of the core, select the ironmongeries that comes from different parts of the world, and when they test, all of them work together as a system. You cannot just say that this lock set, I test with this door, and I can rate it as 4-hour rated lock set. There's no such thing. Until you test with this door, it can only be related to this particular door model. It's a system.
And basically, if you have the components which already have the testing being done, I don't need to resubmit again. Basically, what I need to submit my fire strategy related to the whole system only, not the components of the system.
Maybe Sebastian could take that question.
I mean, I give you one example. When the NASA was sending people to the space, they tested components, but for example, they have not done a test of the full spacecraft. That was not spacecraft at that time, but the full launching capsule at the initial stage. And they have a loss of few astronauts because they not tested the whole system with the oxygen which they used at that time. So my understanding of the Hyperloop, which is a very high expectation, is like a spacecraft technology. So I think it's not enough to test just the components, because you are on the edge of like a spacecraft industry, because there may be lack of proper testing requirements for your system. And it's not enough that you test your product according to existing methodology. Because if you look for the code here, the code says for an unusual project, which we had today an example of Museum of the Future, there is some additional requirements which go beyond the current legislation. And museum is just a building, and your system is like with very high expectation, but the requirement of the safety, you have to, as a provider, demonstrate that they are really far beyond what is expected. So coming back to the point, for example, is testing according to the burn-through test relevant to the fuselage of aircraft enough? Partially, yes, but because your system is so unique, if you go by the code requirement, it says that to the discretion of civil defense, for example, here Dubai Civil Defense, some mock-up or full-scale testing may be required, which is not prescriptive, which has to be designed for the purpose to demonstrate that a unique system, and you are an example, is matching the safety requirements. So for sure, component testing is not addressing the expectation which the UAE and other countries expect for such a system, which is really on the edge of the spacecraft industry. So for sure, you have to go much beyond that.
Thank you very much.
That's a very good question, and I think that ties back into what Karim was saying about design. the whole design should actually meet what is approved and then tested. Be wary of any material changes during construction, because that can cause future problems. If we go out to the floor again for another question.
Yeah. Dr. Abdulaziz Larifi from Sagar Consulting Engineers. Basically, my question is about the theme of having a local standards or local requirements based on the circumstances here. Are we talking about, we know there is a difference between codes and standards. Are we talking about changing performance criteria in codes, or are we modifying standards to have special modifications to the region? Which one are we going towards? Which direction do you feel is the best way forward?
I think maybe John, would you like to comment on that?
So the question is, if we're really wanting to go toward performance, what's the best way to get to performance? Are we changing codes or standards? I think, I mentioned the word commissioning. Paul, I think you kind of talked a little bit about commissioning as well, too. And commissioning is performance-based. It says, in the beginning of the project, what are we trying to achieve? And you outline all the objectives, and you use all of the tools at your disposal to get there. So you're not changing codes, you're not changing standards, but you're taking the ones that are applicable for you to get to that performance, and that's what you're doing. And so the key thing is identifying what's the performance that's needed for the particular product or project, and then using all the tools to verify that performance. Key aspects of it is you try to do it as early as you can. And so if you can do a test or a judgment early on to verify that, then you do it. You want to look at things holistically. We talked about the small versus large-scale testing. We don't use the small-scale testing to avoid the large-scale. We use it to supplement the large-scale. But at the end of the day, we're trying to think about the end and take all the quality assurance steps throughout the process, design, fabrication, and installation, to make sure that performance is met.
Thank you, John. Again, that was a very, very important point to get over. I think we've actually now run out of time, so just before I hand over, just to reflect back on some of the comments the panel have made, I think looking at it's a fuller understanding of the built environment, and we've got a range of professionals from operational, firefighting, fire safety consultancy, and testing and commissioning. And I think within the room, we need to, as designers and professionals, get out of our own individual silos and actually start talking amongst one another. Because it's only through talking and establishing the criteria that they're all trying to design to and get the performance requirement to that we'll actually get a safer building structure. And Terry, did you say one more question?
My name is Sohail. I'm calling. I'm from Material Lab. Heat release rate. Yes, it is very important parameters because with the help of this, we can measure the smoke mass, flame spread, and smoke volume and maximum temperature. I have one question to Dr. Sebastian, that here most of the times there are 4 bodies involved in the project. Contractor is there, consultant is there, inspection and certification companies are there. For the labs, basically it is ISO 17025, and this code is saying that lab will issue only factual report. We are not involved in the judgment of pass or fail criteria. Can you please elaborate this? Thank you.
I think that was a question directed to Sebastian.
Thank you for the question. I mean, basically, the pass-fail criteria depends on the test. So very often in the European approach, it's not pass-fail, but there's a classification. So you have like set of classification criteria, and the laboratory, yes, is doing just the fire testing. But I believe if you look for, you refer to ISO 17025. So one of the requirements of the test standard is that the laboratory cannot I don't want to say misguide, but misinform the potential client which testing standard should be used. And this is the laboratory duty to advise the client. Of course, the ISO refers to obsolete standard, but I strongly believe that duty of care goes beyond that, and it's to explain that there are, let's say, safety implication of using non-appropriate standard, and explicitly ISO 17025 refers to that. And regarding the pass-fail criteria, it depends on the test standard, because if you look for the code, there are requirements that some of the test method, it's just that the reports comes with the pass mark. And the pass mark is well defined. It's not the laboratory who defines the pass mark. The pass mark is either stated in the code or in the classification or in the different codes, depending on the applications. I think that would be my answer.
Thank you. That was, if we can just draw that to a close now, and I'd just like to thank the Brigadier and the discussion panel, and if you could put your hands together in the usual fashion just to thank the